add point. Okay. List object has no attribute add, that's true. Great. And so now this is super slow, the way it's supposed to be. This is a 5-second clip, so we're getting 5 dots. So we should add up points per second. And here we'll multiply by points per second. Okay, and then that's way faster. So the next thing I'll do is I'll color them based on whether they're inside the circle or not. So there's the dot and it's positioned. I'll have to find if the dot is inside the circle. So there is a geometric way, a purely geometric way to do this via cross products. But I'm not going to do that. It actually would be pretty hard to do in this case because a circle isn't a polygon. And you have to do a check for like each edge. But we do know the equation of the circle is going to be 3 squared equals x squared plus y squared. And that's because the circle, by default, the radius will be 3. Will be 1, sorry. And I scaled that up by 3. So this is the equation of the circle. So the way we're going to test if a point is inside it is we're going to check if 3 squared is greater than or equal to the point's x value squared plus the point's y value squared. So we have point right here. I'm going to say if 3 squared is greater than or equal to point at 0 squared plus point at 1 squared, then it's inside the circle, and I'm going to color the dot blue. Otherwise, make it red. Okay, so what we should see here is the points inside the circle being blue, points outside the circle being red, and that's what we see. We add some more points per second. Great. So now we're going to want to compute our estimate of pi from this. So I'm going to just have pi estimate. And I'll start that at 1, I guess. And then what I'll do is each time a dot is added, I'll update our estimate of pi. So when a dot was added, like here, I'm going to say, I guess here. First I have to write out how to compute the estimate. So, the area of a square, that's the side length squared. Area of a circle, that's pi times the radius squared. The radius, in this case, that's going to be the side length over 2. And so, if we divide the area of a circle divided by the area of a square, you'll get, well, let me multiply the rest of this out. This is s squared over 4. I think that's a bit too loud. The s squared over 4. So then we divide this, we'll get pi times s squared over 4 divided by s squared, and so it'll just be pi over 4. Great, so we can take the number of points inside the circle, divide by the number of points inside the square, that'll get us pi over 4. So, get points inside circle, which I now know I have to update that somewhere. So I'll just have points inside circle. And when there is a point inside circle, I'll update that. So here. And then I can update the pi estimate. So here. And then I can update the pi estimate. It's going to be the points inside the circle divided by the total number of points. It's just length of points. And I have to multiply that by 4. Okay. Points inside circle. Saying this is unbound, so I'll just use non-local for points inside circle. Great. And right now I'm just going to print this pi estimate. I'll probably need more points to get something close to pi. Let's just see this. I get a division by 0 somewhere, which makes sense. Where do I add to points? I have to do that beforehand. Okay. So just from this printing, you can see this is kind of getting near pi. So that should indicate to us that we're doing something right. Okay, so next I'm going to have that value actually appear somewhere. So I have pi estimate mobject. That'll be a decimal number. And I'll just have pi estimate. And I'm going to give it an updater. And that updater is going to update its value. So just mob.setValue. Great. So let me just move this next to the square. Like so. We add it. Okay, and hopefully we'll see this number on the screen. And it's not updating. So let's see why that's happening. Looks like this is declaring a new pi estimate variable. I think I can do this. And update pi estimate is not accessed. So I didn't add that updater. So I have to do pi estimate mob. And the music is talking, which I don't like. There we go. Add an updater. All right, so let's see if this updates the value for us. Great, and so now this is updating over time. It's getting kind of closer to pi. Just to make sure, just to show that this is supposed to be pi, I'm going to have another mobject for the approximately part of the equation. So I'll call this pi approx. I'll do a map tech. It'll just be this. This is just pretty simple LaTeX. And I'll put this next to the square on the right. And I'll put this next to pi approx on the right. Then I'll add both of these. Okay, so hopefully now we'll see pi approximately, and then we'll see that decimal. Great. And so now this is showing us the estimate of pi based on these numbers. So the only thing left to do is to make this, is just add way more points and see if we can get something that's actually close to pi. Because right now, that's actually closer to pi than I sort of expected. Usually, I did it one time and it was like around 3.1, less than 3.1. And I'll see if I can get a better estimate now. Nope. Well, it's doing it again. See that? It makes me wonder. Well, actually, let me see if I can increase the... It's doing it again. See that? It makes me wonder. Well, actually, let me see if I can increase the number of decimals in the decimal number. Num decimal places. Let me put this at like 5. And add even more dots. Since that seemed not to slow down the rendering too much. Let's see if we can get a decent estimate. Okay. Yeah, I don't know. I wonder if... No, I don't know. I guess the estimate is just gonna be, like, not that good. It's, like, close enough that I don't think I made an algebra mistake. But then far enough that I think there is some mistake. Who knows? But anyway, that concludes the final Manim lesson. The final offering of the final Manim lesson, I guess. So, as of this point, you now passed learning Manim. Congratulations. It is true that this course we ended up giving up was pretty disorganized, and I apologize for that. We're probably going to end up doing one in the future, more focused on 3D and things like that. And we're going to have to organize it a lot more for that one. So if you stick around in the Discord, which is here, I've been told you can maybe get it from !Discord. I'll try typing that, but people have said that it doesn't appear. If not, it should be beneath the stream. So you can also just look beneath the stream too. Okay, and that's all. Thanks for watching. I'm not gonna end the stream though. I have a tweet that I want to work on and hopefully get finished in a few days. So I'm gonna start working on a tweet now. But yeah. Thanks a ton, guys. And I'll be happy to take any questions if you have those. Okay, I'm gonna bring up this tweet now. If I can find it. Just call this lens and see what I have so far. Okay, I think that's good. I think the writing might be a little fast now. Maybe I'll make this like 3.5. And then this, if I want this to be 1.5, that'll go up to 5. Okay, I think that's good. Especially if I make it go past the end a little while. Where it's already at 5, I can bring this to like 7 or so. It'll just be 2 seconds. Okay. So That looks good to me. Is it slowing down? It is slowing down. Rate func equals linear 3.5. It's slowing down here for some reason. Setting the value to 7 over 2 for some reason. Setting the value to 7 over 2 seconds. This should move it at the same rate. Oh well, I can figure that out later. Right now, I'm going to go over when this distance is fixed. So I'm going to... I wonder how to illustrate the concept of this distance being fixed. I think what I'll do is I'll just change the color of the arrow. Also, I need a new song. I wish I could just listen to Spotify or something. But I guess that the image arrow dist. I don't think it's dist. What was it called? The arrow that... This one. Image dist arrow. I say image dist arrow dot set color. I'll set that to gray. And then continue for another like 3 seconds. Okay, so now we have, it tells us this text, writes out this equation. Okay, then it does turn gray, but then it keeps moving. So what I'll want to do, I think I just wanted to set it to gray and then just wait. And it won't be just waiting, but I guess I can start from N3 or so. Oh, N3 is like the whole thing. I'll do this, then stop it. Great. That actually looks how I want it to. So it'll just stop there. So what I'll want to say is if one of the distances is fixed, so I want to say fixed distance explanation, and this will be tech. It's going to say if the distance to the image is fixed, the distance to the original can be modified. I should say distance to the original will still change according to the lens maker equation. I'm probably going to replace this text with this, and then I want to make sure the lens maker equation isn't something I made up. I have to search it better than that. Where is it? Okay. So basically this. And the reason this is helpful is because it has the thickness. And the thickness is what's changed in your eye. So why don't I here, I'll fade out the thin lens equation. And then when this pauses, instead of just waiting here, I'll do a play right of the fixed distance explanation. This needs to be moved to the top. Okay, so now let's just move to the top. Okay, so now let's just take this from the top. This distance given by the thin lens equation. I faded out the wrong thing. Yeah, I wanted to fade out the description. And this also tells me this needs to be scaled. Got the scale factor at 0.7. Honestly, both of these should be faded out. So let me just fade out a V group of description and the thin lens equation. Actually, not the thin lens equation, just the description. Because the thin lens equation shares part of itself with the lens maker equation. And I want to show that. Man, that faded out slow. Let's make that 1 second. Now if I check it from animation 3, animation 2, okay, so this is good. Now, what I want to do is morph this 1 over f into this. I'm just going to write this, then I'm going to do a self dot, probably replacement play of a replacement transform. And this will be very annoying to do since it deals with LaTeX. So let me see how I can even split this up. I remember trying to split this up before. Maybe if I do this, a plus sign, this, the equal sign, and then this. That should make it a little bit easier to index if it doesn't just crash everything. Which I think it's just going to... I get the feeling it's going to render something wrong, yeah. I can actually tell why, because here it's trying to write an empty brace, like these empty braces as tech. I think if I take out the tech to color map, yeah, then that'll actually do it. Okay, now I don't know why it stopped. Oh, it's because I'm replacement transforming nothing. So now I can replacement transform 0, 1, 2, 3, 4. It'll be thin lens equation at 4. I'll just do it into a square or something, just to make sure I'm indexing it correctly. Okay, so I get this. Stops. Great. That's perfect. Now, instead of being a square, I'm just going to want to transform that into the right-hand side or whatever of the lens maker equation. And for that, I have to bring this over. Where is it?